Hello there. So today I'm going to talk about machine learning.
It all began with a 1942 study by logician Walter Pitts and neuroscientist Warren McCook that sought to logically map out human cognition's thought and decision-making processes. The Turing test, developed by Alan Turing in 1950, became the yardstick by which machines were classified as intelligent or unintelligent. It was necessary for a machine to be able to persuade a human being that it was likewise a human being in order for it to qualify as an intelligent machine. A summer study project at Dartmouth College soon later became recognized as the beginning of AI. Machine learning is a branch of artificial intelligence, AI, and computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy, adapt without following explicit instructions by using algorithms and statistical models to analyze and draw inferences from patterns in data. The machine learning process begins with observations or data, such as examples, direct experience, or instruction. It looks for patterns in data so it can later make inferences based on the examples provided. The primary aim of machine learning is to allow computers to learn autonomously without human intervention or assistance and adjust actions accordingly. Machine learning is not science fiction. It is already widely used by businesses across all sectors to advance innovation and increase process. In 2021, 41% of companies accelerated their rollout of AI as a result of the pandemic. These newcomers are joining the 31% of companies that already have AI in production or are actively piloting AI technologies. One of its examples is healthcare. Machine learning is used to analyze massive healthcare data sets to accelerate discovery of treatments and cures, improve patient outcomes, and automate routine processes to prevent human error. For example, IBM's Watson uses data mining to provide physicians data they can use to personalize patient treatment. Other example is retail. AI researchers and developers are using machine learning algorithms to develop AI recommendation engines that offer relevant product suggestions based on buyers' past choices, as well as historical, geographic, and demographic data.
So there are three types of machine learning. Firstly, it is supervised learning. Second, unsupervised learning. And the third one is semi-supervised learning.
Supervised learning. The input is in the form of raw data that is labeled. The machine is already fed with the required feature set to classify between inputs, hence the term supervised. In this type of machine learning, data scientists supply algorithms with labeled training data and define the variables they want the algorithm to assess for correlations. Both the input and the output of the algorithm is specified. For instance, is it a cat or a dog? Image classification is a popular problem in the computer vision field. Here, the goal is to predict what class an image belongs to. In this set of problems, we are interested in finding the class label of an image. More precisely, is the image of a car or a plane, a cat or a dog? Unsupervised learning. The machine is given huge sets of data that are not labeled as inputs to analyze, and needs to figure out the output on its own by identifying patterns in the raw data provided to it. This type of machine learning involves algorithms that train on unlabeled data. The algorithm scans through data sets looking for any meaningful connection. Therefore, the data the algorithms train on, as as well as the predictions or recommendations they output are predetermined. For example, suppose the unsupervised learning algorithm is given an input dataset containing images of different types of cats and dogs. The algorithm is never trained upon the given dataset, which means it doesn't have any idea about the features of the dataset. The task of the unsupervised learning algorithm is to identify the image features on their own. Unsupervised learning algorithm will perform this task by clustering the image dataset into the groups according to similarities between images. Last but not least is reinforcement learning. Data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative clues as it works out how to complete a task. But for the most part, the algorithm decides on its own what step to take along the way. As an illustration, suppose there is an AI agent present within a maze environment, and his goal is to find the diamond. The agent interacts with the environment by performing some actions, and based on those actions, the state of the agent gets changed, and it also receives a reward or penalty as a feedback.
I guess we already arrived at the end of the video. Thank you for listening and goodbye.